Okay, so here we're going to look at the transformations in terms of the coordinate plane. So in this unit, we're going to first look at the transformations on the coordinate plane, what happens to the coordinates after translations, reflections, and rotations. And then we're going to look at ways to represent translations, rotations, and reflections in terms of drawing them and then using function notation. So the translations portion of this you should be very familiar with. We talked about this in the first unit, and we looked at coordinate changes for horizontal and vertical shifts. So, transformations, a translation is a shift or a slide. Translations are isometric, which means they preserve the shape and the orientation. So with a horizontal shift, and I'm going to go ahead and apologize, I don't have my stylus, so I'm writing this with my finger. So the horizontal shift affects the x value of our coordinate. Horizontal left and right is going to be our x value. When we shift right, we add to our coordinate. When we shift left, we subtract from our coordinate. So horizontal, x value, right we add, left we subtract. So for our vertical shift, this is going to affect the y value. When we shift up, we add, and when we shift down, we subtract. All right. So x comma y, the way we want to represent this is we can write x plus, oops, I say x plus or minus h to represent horizontal. Let's match my colors here. X plus or minus h, y plus or minus v. So the h represents my horizontal value. However, we're adding or subtracting, moving left and right. The y is going to represent our vertical. The v, we add or subtract. Okay, that one's pretty easy. This should be all a review in terms of the translations. Now, reflections are where it can get a little bit more tricky. So when you're looking at reflections, this is a flip. So if a flip is performed over a line of reflection. So lines of symmetry are examples of reflections. Reflections, again, are isometric, so they preserve the size and shape of whatever we are reflecting. Okay, so when we reflect, we first can reflect over the x-axis. So think about your xy axis. So if this is my xy axis, and let's say I'm looking at this point, okay, we'll call that point 2, 3. If I'm reflecting over the x-axis, okay, that's over this guy. So we're just going to reflect it over. Now with reflections, it's going to be the same distance away from each of these values. So whatever the distance is from my x-axis to my point is going to be the same from my x-axis down to my point when we reflect it. So when I reflect it here, the x value does not change, right? So because my x value is going to stay the same, it's going to be on this vertical line. When I reflect it down, my y value is going to change. And now I have 2. I was 3 above, now we're reflecting 3 below. So if I were to reflect this, if this was my line of reflection, since this was 3 coordinates above my x-axis, is now going to be 3 coordinates below my x-axis. So the x values stay the same. What changes here are your y values. Now the only thing that changes though is the sign of the y value. So if it was positive, now it's going to become negative. If it was negative, it becomes positive because it's still the same distance away from that axis. So over the x-axis, x stays the same. I use negative y to represent a sign change. Now that doesn't mean it's always going to be negative. So if we started with a negative value, so like 4, -6, we are changing the sign with the negative here. So it'd be 4, +6 because a negative times a negative is a positive. Okay. So then over the y-axis, so let's go back to our point 2, 3. Here's my y-axis. So if I'm reflecting, here's my line of reflection, or here's the line that our point is to stay on. Now, I'm still at a y value of 3, that's not changing. So I was 2 coordinates to the right, and we reflect to be 2 coordinates to the left. So if it was 2, now I have negative 2, 3. So here my y value stays the same, my x value is changing signs. Okay, so over the y-axis, negative x comma y. Y stays the same, x changes sign. So if it was negative, it becomes positive. If it was positive, it becomes negative. Okay, so looking at the line x equals y. So again, if I have my coordinate plane here, the line x equals y has a y-intercept of 0 and a slope of 1. Okay, so that's going to look like this. If we were a little bit more official with the coordinate grid, you'd be able to see it better. So what happens here is we're reflecting across this line. Okay, so when I reflect across this line, everything's changing position. So if I looked at the point, let's say this is 3, 1. If I'm reflecting over this line, it's going to be up here. That's not going to be 1, 3. So what happens here is my coordinates are switching spots. Okay, they're switching spots, they're reflecting. So what was x is now my y, what was y is now my x. So x comma y becomes y x. Okay, and then the last one in terms of reflecting is we can reflect through the origin. So remember your origin is your center point 0, 0. So if I'm reflecting through my origin, this is a little bit harder to draw. Your coordinates stay in position, but they change sign. So like if I was looking at, let's say I had like 2, 4. If I'm reflecting it through my origin, oh, that's a little squiggly. If I'm reflecting it through my origin, it might be down here, which is now -2, -4. So the numbers, the values are staying the same, but their signs are switching. So again, through an origin, we can represent it as -x, -y. X and y are not changing position. The only thing that's changing is the sign. So if they were negative, they're becoming positive. If they were positive, they're becoming negative. Okay, so there are the 4 coordinate rules for reflections. You definitely need to know these, you need to memorize these. You will not be able to add these to your notebook. Okay, so for rotations, rotations are our turns. So again, we have an isometric, or rotations are isometric, which means they preserve the size and shape. So when we rotate something, the size and the shape does not change. So when we're looking at rotations, we're only going to look at rotations around the origin in terms of the coordinate plane. In class, we'll look at some drawings where you can rotate around different points, but in terms of the coordinate plane, we're only rotating around the origin. So we have 2 directions. We have clockwise and counterclockwise. So a 90-degree counterclockwise rotation, or excuse me, a 90-degree counterclockwise rotation is the same as a 270-degree clockwise rotation. So both of these rotations are going to give you the same result. So in terms of the coordinates, with a 90-degree counterclockwise rotation, if I start with xy, I apply my rotation, my new coordinates are going to be negative yx. Okay, so the coordinates are going to switch locations. What was in my y value is now negative. Now, when I say negative, I just mean the opposite sign. It's not always going to be a negative value. So if it was a negative to begin with, it's going to become a positive. If it was a positive, now it's a negative. So I can use this 90-degree rule to kind of build the rest of my coordinates. So if I start with a 90-degree rotation, so if I'm starting with negative yx, if I apply another 90-degree rotation, I'm going to use the same rule. So negative yx, they'll change locations, and what was in my y is now negative. So for a 90 plus a 90 is 180 degrees. Your new coordinates are negative x, negative y. So from beginning to end, they stay in the same location. Both of the signs change. But from a 90 to a 180, they switch locations, and what was in your y value changes signs. So again, if I want to start here and apply another 90-degree rotation, that's going to build up to a 270 counterclockwise total. If I use the same rule, they change locations, what was in my y value changes signs. So y negative x. So from beginning to end, they change locations, what was in your x value, it changes signs, but from a 180 to a 270, we can use that 90 rule again. So these are very important. You have to memorize these. Okay, you need to know how to use them and which rotations go with which coordinate planes for both directions, counterclockwise and clockwise. All right, so the last thing I want to touch on is our notation. So we talked about this briefly when we looked at translations, and that is if we start with a pre-image, we apply our transformation, we then have an image. So the way that you showed that in terms of coordinates is with this prime notation. So if I start with point A, apply my transformation, my new point is A prime. That's A with the apostrophe. All right, so make sure you write these down. Now I want you to try the practice problems on the back of this worksheet and reach out to your teachers if you have any questions.